Right, so welcome back to Advent of Code, and today we are gonna solve day 19. So for day 19, we reached the hot springs, and suspiciously enough, okay, it's a YouTube video, nothing goes wrong, right? But we get a chance to visit the onsen. What is an onsen though? It's like a hot spring. Okay, like a you know how people go and do sauna and stuff, something like that, I guess. And we have a brief conversation with the reception staff, and we figure out that there is a problem with their towels, or I guess they want to arrange their towels in a specific way. And each towel has some kind of pattern of color stripes, and they can be either white, blue, black, red, or green. So these are the symbols that we're gonna see throughout the puzzle input. So a towel with the pattern GGR is gonna have basically what, green, green, and red stripes. All right, in that order. And it says that we cannot reverse the towel because that would flip the logo of the company upside down, so we don't want that. And what do we want to do is to we basically have a set of towels, right? And some kind of let's call them patterns that we want to design, let's say. And the idea is, how can we combine our towels such that we get the specific design? And what I'm not sure about, so it says that we can arrange. Can we reuse a towel? So do we have unlimited towels of these types, or do we have only one? That's an interesting point. So we get the puzzle input, which looks like this. Right, I might even just copy it for now. The first line indicates the available towel patterns. In this example, the onsen has unlimited towels. Okay, so it's unlimited. Perfect, that's pretty interesting. So it's like, if you know dynamic programming, the coin change problem, something like that, because we want to get some kind of sum, but in this case it's string concatenation, but you know, it's still something. In this example, 6 of the 8 designs are possible with the available patterns. So we need to count how many designs are possible. What are the chances that for part 2 it asks in how many different ways we can achieve the design? Or maybe something like, what if the towels are not unlimited? So should we try to solve it in a way that will make that easy, or should we just go ham and try to get just the first part done and then we'll see for part 2? I guess, you know, both make sense. I kind of want to solve it in a dynamic program because I don't know how to do that. Usually in these kind of problems, first thing I do the recursive solution because that's easy to figure out. It's not that complicated to get the recursive solution. Then memoization is kind of easy to add to that, but going from the recursive solution to dynamic programming, for me it's impossible. Like, I don't know how people are able to get that. So let's hope that the like for part 2 is gonna ask for like how many combinations we can have per towel, and we have to add those or something, or multiply those numbers if they are not 0. So that's my hope. Or the other one is that, you know, the number of towers get limited somehow. But yeah, let's see an example of how I think about this problem actually. So let's say we have BR. So these are the stripes, BR, W, R, R. Right. So my idea would be to recursively do like a recursive function, and we'll have a for loop over our towels. So we can also look at the puzzle input just to see how big it is. It's kind of big, not gonna lie, but it doesn't matter. So we have a for loop over all of our towels, right? And we say, okay, what would happen if we choose to use the first one? So the first one is R. Well, if we use the first one, it doesn't work, so we just go next. WR also doesn't work, but we get to B and B works, right? So we say, okay, B works, and we are going to be left with this substring that we need to complete in the next iteration. So now we have to go recursively and basically start over. Now, obviously, if we do it like this, at some point we are gonna repeat the same pattern. So you can see that here we find the B, then we go recursively, we find R, and we are left with WRR at some point, right? And let's imagine that we are able to solve this one as well. But you can see that here we have BR. So at some point in the first iteration, we find that, okay, we can even use BR. And we found again WRR, but this one we already solved in a previous step. So we can just say, okay, if like certain substring was already solved, there's no point in recursively going into that string because we already know the solution for it. So I think that's the optimization step that we can do. So it's like, let's say again, we select B and we say, okay, we want to choose B. Let's see what happens if we use B as the first towel. So we remove the B and we have this left. And now we have to say, okay, let's check if we already solved this string. Did we solve it? No, then we have to solve it. If we already solved it, we know the solution, right? So that's the recursive with memoization. That's how we are gonna do it. Okay, so hopefully that makes sense and we can start with the code. So yeah, let's go to the code. Okay, and for today, as you can see here, I was thinking to use TypeScript, and I know we already did JavaScript at some point, but TypeScript is a different language. I mean, it compares to JavaScript, but it's different. Trust me, there's no worries about doing a duplicate one. So, okay, anyway. First thing that I'm gonna do is actually steal the code from JavaScript. So I wanted to read the input, right? So let's try to read the input. Wow. Let me just... interesting, but... You know, that's gonna be kind of annoying, I guess, with TypeScript. Actually, I don't remember how you make it TypeScript read from std. Right, like it should be the same thing, but function main, and we have like, let's call this one input, and our input, it's like I mean, actually it could be just wait, the first thing in the like the first line is a single. Okay, yeah, perfect. So it's a single line, then nothing, and then multiple lines. Okay, so we can just say that this is the input, and well, it is what it is. So we have the input, which is a string, Let's check if this thing works. Huh. That sucks because I have to add types node. That's crazy. npm install types node. I mean, I hope that I installed everything, but apparently not. So there's also process that it doesn't like. Wait, is it like this? Import star as readline. Or is it as readline from? I don't remember how to do. Okay, that's how you do it, but is this like process is undefined? So TypeScript process is not defined. Whatever. Once you have installed types node in the project, you can tell TypeScript. Yeah, whatever. Maybe it's something I have to add in ESLint or something, right? ESLint. But if it compiles, it compiles. You know what? Let's just ignore that part of the code. Maybe we can even add multiple new lines so we don't see it. Okay. So if we do console log input and we do like make run tmp, right, we get the input as expected. I mean, maybe it makes sense that the input is a string and we say something like, or no, I guess we can like join on a new line, and here we are getting a string, so it's basically just a way of us reading the input. Okay, so we can make a function parse input which takes a string, and let's have like a type for our input. I mean, it's kind of pointless, but because we can just say, okay, we just return the string like the, no, should be like a string array for the towels, right? String array for the towels and a string array for the puzzle or puzzles, I guess. So we say something like input.split. Can I split by two new lines? I forgot. And then say something like towels line and puzzles or puzzle block or something. Console log towels line. Can I actually see this? And I don't like just return empty lists for now. Okay, and puzzle block is what exactly? So it should be like that entire thingy. Okay, nice. And maybe what I want to also add is a trim. So we trim the string. So towels line dot split. I guess we can yeah, split by comma, right? So it's basically by comma space, and we get those strings. So const towels and then const puzzle block. I'm gonna use stream, why not, just to make sure split by new line. So here we just return towels and puzzles. Towels, oh shit. Towels and puzzles. Okay, so we should see like two lists. All right, perfect. So that's the thingy. So now let's have a function that takes in a single puzzle and a list of towels and tries to generate the like maybe I don't know, I like either the number of combinations, or I would really like to get the list of towels that are used, because that's gonna look really cool just to see that. But maybe first it's just gonna be like a boolean if it's true or false, just to make sure that we get the right answer, and then we can improve it, like actually displaying the towers that are being used, because that would be pretty nice. Anyway, so as I said, this thing should get in a single puzzle, which is a string, towels, which is a string array or list, and it's gonna return a boolean, which is like, does it work or does it not work? And the name of the function will be like solve, or is can design. So it's then return true if we can design this puzzle with our towels, or I guess this should be pattern, maybe patterns, right? Let's call it patterns. Right, so we can do like for I mean const pattern of patterns, ideally would be I is equal, let I is equal to 0, I is less than patterns dot length, and then something like can design patterns I towers, maybe like if we can design it, maybe answer 1, we can even say something like part 1 answer 1. Right, so that's basically part 1. I was expecting it to say 0, but I have to say return false for that to work. So yeah, it's gonna be 0. Alright, so how can we actually implement this one? So I guess the base case, right? What's the base case? Well, the base case is if the pattern is an empty string, then we return true. I might even just add the squirrely braces, because we might do something in the future. So if the pattern is empty, we just return true. Then what do we have to do is for let I is equal to 0, I is less than towels dot length, I plus plus, And we should do something like, I mean, at some point we have to call can design on, so let's take the towels of I, then pattern maybe pattern suffix is gonna be basically pattern dot slice. So we start with the length of the towel, right? And we end at the end of the string, so should be something like towel dot length and pattern dot length. Does it make sense? So we basically remove this part, but we have to make sure that if towel is equal to, so let's do pattern const pattern prefix is pattern dot slice. Now we start at 0 and we end at towel dot length. I don't remember if that's actually a thing, but so if these things are equal, only then we can actually do the actual stuff. So for now, let's just do something like this, return false, and I just want to see pattern prefix and the towel. I'm curious. Yeah, it actually looks good, right? So it's the correct length, and then pattern suffix, or I guess pattern prefix, pattern suffix, so we can actually see, yeah, it looks good. So end is non-inclusive, but doesn't matter. So here we have pattern suffix and towels, and we do towels because it's unlimited number of towels, right? So we can send them however we want. Now this thing returns a boolean. So ideally for part 1, if this thing is true, we return true. So we stop and say, okay, it worked. On one of the branches, it worked. We don't care which one, it just worked, right? And if none of these towels are matching, then we return false. So my hope is that we can find at least one that works. Okay, let's see. What do we get for part 1? We get 6 towels, which is also what we had here. But how about our real input? Looks like it takes some time. Like, I'm pretty sure part 1 should be solvable with this kind of algorithm, like the shitty one. But apparently it's not. That's kind of sad. Let's just leave it and see what's gonna happen. Maybe we can even say console.log. I'm curious how much time it takes for the shitty algorithm to run this. Aha. So it takes a lot of time. Then we kind of have to add the memoization already, which is interesting. So we'll have something called memo, right, that gets passed into this thing. And this should be a hash map that goes from a string. So let's say a pattern suffix to boolean, if it was solved or it wasn't solved. Right, So how is this thing gonna work? How is this thing gonna work? So in here, instead of going recursively, we have to say if memo has pattern suffix, then we just return memo pattern suffix, right? Wait, what? Pattern suffix. Okay, anyway. Yeah, whatever. So yeah, basically that's how we are gonna do it. So if we already have the pattern, we don't go recursively into here. But now there's another one, and that is after each call to this thing recursively, we need to save the result. So let's say const result is equal to this thing, and we have to say memo of memo dot set pattern suffix to result. All right, so we have to say that if result is true, then that's gonna happen. So I think that's the optimization. Let's see. Oh, and here we need to say that well, the initial map is a new map string bool eon. Hopefully that's the right way to do it. Right, so you see it's much faster if we add just that small step, right? It's like extremely faster, right? Because we just store all of these, like we already solved this one, right? So what's the point of going recursively into it? Let's see if it's actually correct. Oh shit, it's not. Damn, that's sad. Maybe I missed something like in here. But no, it said you can repeat how many times you want, so and that got me a bit excited. I go, oh, we can actually, like, it's so much faster, but what the fuck? Yeah, like what went wrong actually? Memo set. I mean, that's stupid. Why didn't it work? Hmm. Like it's creating a new variable, so it shouldn't break it like in a weird way, I would say. Oh, I wanted to print this thing, so let's do like const. Like that's kind of weird. I'm just curious, how about if we run it on TMP? I mean, obviously this one is true, this one is true, gr is true. But you know, I was curious about the first one because the first one is the one that I showed as an example. right? So right, like that was the small example I had here, and we found WRR twice. But why it said it's too small, which is like extremely weird. What the fuck? Wait, what if shit, what if we say that, oh, it's false, but we should only say if it's true though. So what if we only have to say here if it's true and here if it's false? But what's the pattern here? Is it like just pattern? Let's keep only the true ones, and it is what it is for false. Yeah, but this still makes it slow as fuck. Yeah, so the thing is, that I don't want to say that one pattern is false. Let's think about it. So hmm. Shit. Damn, I really thought that it's gonna be that easy. So should we maybe instead look at the prefix? I don't think so. Like, no, it should be on the suffix because the suffix is, oh, we solved this one already, right? But the problem is, let's say somehow we got the suffix, one of them, and actually um, somehow that suffix failed, right? It said it's false, but on another way it could be true. So maybe in here what we have to do is actually so we try to solve for a single pattern. Yeah, like what if we actually try in fact to say if this pattern becomes true or false. So yeah, this one stays here as, oh, we already solved this pattern, but we have some kind of let can is equal to false, so we can do that, and here instead it's can or, and here it's just can is equal to can or, and at the end we return can. I mean, it should be okay. What am I doing? So okay, 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 okay. and at the end we say something like memo set pattern okay. What if, does this help? No, it doesn't. It doesn't really help because it's gonna fill it in at the end of the run, so yeah. But see, I think that's kind of the problem. Somehow on the first branch, if one of them returns false, but what if, like, I don't see when that can happen, when you can. I guess let's say we have R, 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 and then B, and the towers that we have are R and RB. So on the first case, it's gonna be like DFS, right? So it finds R, it finds R, it finds R. Then we have B. So the B suffix is false now. But then we return from the recursive call and find RB, and RB becomes true. So RB becomes true though. So the entire thing becomes true. So why doesn't that work? What the fuck? I'm extremely confused about this one. It's funny, you can even see the actual like solution step by step. I want to see one that, so let's see how the false ones look like, because maybe that's more interesting. How does the false ones look like? So there's a bunch of false. So we have like G, which says it's false, or BG, but that's for my puzzle input. So it's like probably I don't have BG, for instance, here, right? Wouldn't even know. Doesn't look like I have BG, honestly. So I would say that's kind of reasonable. I mean, did I miss something? BR can be made with a BR towel, WR, and an R towel. BGR, GB, BR. Then we find EUUBG. Okay, let's see how it looks on TMP, because TMP is smaller. So here for the last one, right? It says that WB is impossible. That's one that it finds. And indeed, it cannot solve it with any of these. So it probably reaches WB at some point. And we know that this one is false. Then GWB, because it managed to do BBR and then it was left with GWB. and it resulted that GWB is false. Maybe it had like G, and then WB became false. RG. B and then BR, BBR. I mean, it's extremely confusing. Why doesn't it work? So let's see like the selected tower and pattern or something. Fuck. So it got to, this was the first one, then I guess I can even say console log already computed, and maybe I just print it just to see what it was. Console log computing. So here it's like, but it sucks that it's you know, called recursively, so it's gonna be like, but this one, for instance, it's already computed, right? And then I guess we have this one is for this one is for this one, and so on. Right, like extremely weird. So when we had this one, memo has, but then maybe we have to check it in the beginning. I mean, part like the first one will always work because it's just pretty easy. But yeah, so we do that, right? So we get a different result now. Weird, does it really matter that I put it there? Looks like it did. Oh, interesting. So I'm wondering why it like, obviously it's less fors, like it's less for loops if I do it here. Huh. Okay, I mean, I just suck at dynamic programming, so it is what it is. The stuff, okay, let's see what part 2 is about. So we don't really like some of the towel arrangement, so we should give them every possible option. Oh, so we have to do the total number of combinations, right? So instead of boolean, we'll have to return number basically, and here is gonna be designs, or I guess count the designs. Shit, count design. Yeah, whatever. So here we return one design, right? Memo is gonna contain hopefully a number. OK is gonna start with 0, right? And here, instead of doing OK or, we do OK plus. Count designs. Here we set, and here we return OK. I mean, OK should actually be count. Right, so it's exactly the same solution, but instead of using a boolean, we use a number here. And here we have count designs. If it's greater than 0, we have first answer, and answer 2, it's just gonna be, wait, shit. Count is equal to, so if count is greater than, and answer 2 is incremented by count. Alright, so that's how we also get the second answer. Right, so quite a lot of them. Let me just double check on TMP. Should be 12, 16. Okay, so it actually is the right answer. Wow. Yeah, I mean, that's it was a pretty fun one. I mean, I just suck at dynamic programming, so obviously this one got it wrong the first time. I don't know how. But yeah, that was Advent of Code day 19. Hopefully it was interesting. The only thing I want to do now is let's try to actually generate the actual patterns. Maybe that's interesting to do. Let's see. So first I'm just gonna I guess just do a commit. And what if here, let's think, so we have a number. So I would like to keep so here it's gonna be a string array of what pet, or I guess number array of the indices. Maybe it's easier to just keep the indices. Right, so we'll have the indices of the towels that we used, right? Thing is, this thing must return a 2D array. So we need as well here a result, which is going to be number. Right, so here we need to return the result. If we have the pattern in the memo, then we have to do what? I think we need to return, shit, how is it gonna work? Maybe not, maybe here it's just the current result, so it's a single list. Right, and here we return it like this. And if we already found the solution in our memo, we might want to return something like this. So if we found the pattern, then but see, it's a bit weird because I think the map should have all the options. I think the map should have all the options. So if you can, yeah, I think it should be a list of lists here. So then this should just be that. And now it's gonna be more interesting here. So the result is gonna be basically result plus the index of the towel, right? And here, instead of count, we are gonna have some kind of options. It's gonna be an empty list. And here, let's say const options. Can we options dot push opts? So basically count designs is gonna give us all the possible options, and we push them. Then we set the options here and we return options. Right. I think that's how it's supposed to work. Right. So here is gonna be number. Count designs is gonna start with an empty list. And here we have options, and then options dot length. Right. And here it's gonna be, let's see if we get the same answers. Right, we get the same thing on TMP. Shit. Whoa. Whoa. It's too big. Interesting, so it's too big. Huh. I guess then sadly we cannot generate the total number. I was like, oh, let's see, that might be cool, but apparently we cannot. Unless, let's see, so for TMP at least we can see the options, right? Wait, let me also, so let's map, and we get opts, or how do I, opts, and then we can map opts, and it's like index, and we can even say towels index. Okay, I think that's gonna give us the towels themselves. So you can see for the first one, let's see, it repeats itself. Right, it repeats itself, so maybe 1 2 3 4 5 6 7 13 14 15 16, but why does it repeat itself? So BR like that. Why does it repeat itself? Maybe I have to do something like slicing it. Well, what the fuck? I mean, why does it? Something's a bit suspicious here. Right, so it's the right answer, but I think it's a problem with the JavaScript. Yeah, I think it's like a JavaScript issue now. It's a skill issue with JavaScript. So memo has pattern, we return this stuff. Here we set options. I mean, I don't know. Like just copy them, I guess. Make sure we don't, but it gives me the same stuff twice. But it cannot really, like, I don't see how it's being duplicated. But OPTs look the same for some reason. Here we put I, which is this I, current result plus I. Um, hmm. Yeah, I guess we cannot really do that because if it's already solved, then we don't solve it anymore, so we don't really get the, yeah, I mean, I guess to get the, like the real indices, we have to simulate it entirely, so we cannot memorize it, and that's, if you remember, it didn't really work, so I don't think it's possible to actually see which indices. Like we get the same indices twice because it was memoized here and it said, okay, this is the first solution that we found, right? And next time we find something that tries to use that solution, we say, okay, use this one. Don't compute another one. Just use it. It is what it is. So that's why we cannot really generate the like all the solutions, which is kind of sad because yeah. But let's see, it's fine. I mean, we got the actual problem, so yeah, I guess that's it for today then. We managed to solve it in I guess in JavaScript, but it's with TypeScript flavor. And I mean, you know, honestly, if you don't use TypeScript, then I mean, we have a problem. Like, why would you use JavaScript when you have this extra step that gives you a bit of safety, right? A bit of type safety. It's pretty useful. But I mean, you know, if I do like a really simple HTML web app, I might just use JavaScript. Although in this case, I did this showcase for each day, and it's also like a simple HTML app, right? With just HTML and Webpack. So it uses Webpack to combine like HTML with JavaScript, and it's using TypeScript because I thought that, well, it's gonna be better to just use TypeScript because it's giving you these types, and also the LSP is much better. So yeah, I mean, you know, just an idea. So yeah, I mean, we are pretty close to actually finishing Advent of Code. which is pretty awesome. And I mean, this was an interesting one, an interesting day. With a pretty, like, it wasn't a hard solution if you like had experience with these kind of problems, which I had a little bit, but I don't really like DP problems, so yeah. But I would see that if you are completely new to like problems like this, then this one would feel extremely difficult. Or let's say you wanted to solve it in Haskell, then look how small this count designs is compared to I mean, even in Haskell you can do DP like I did like last year and 3 years ago in Haskell, so it's not that big of a deal. We can use hash maps as well there, but you need third-party dependencies, if I remember correctly. So, and they are much slower. But in the end, it still works, right? So, but you can see how easy it is here. You just have the base case. Yeah, I mean, didn't get it first try, but now it makes more sense that it's these are the base cases and this is the recursive call, right? So yeah, this was day 19. So hopefully you enjoyed and learned something new. So see you in the next one. So bye bye.